So we were in the double angle identity part, and we had learned those three different forms of double angle. Well, not three, four things. So we learned that sine squared x, or sine of 2x, sorry, is equal to 2 sine of x cosine of x. You guys remember that? And then we learned the ones for cosine. So cosine of 2x. The way I remember it is cosine squared x minus sine squared x. And then if you're trying to get the two other forms for that, you can either replace cosine squared with 1 minus sine squared, or you can replace sine squared with 1 minus cosine squared, right? So there's something called power-reducing formulas. We're not going to technically use these power-reducing formulas, but they are what leads into the half-angle identities. So the power-reducing basically says if you have like something like this, you can solve for cosine squared by adding the 1 over and then dividing by 2, right? Do you guys see how we go from that to this? And then if I wanted to take just plain cosine of x, I would then take the square root of both sides. That leads to the half angle. So it says the power-reducing identities with x over 2 instead of x can be used to find these half-angle identities. So this is what the half-angle identity says. So it says sine of x over 2 is equal to plus or minus the square root of 1 minus cosine of x all over 2, right? And the cosine of x over 2 is plus or minus the square root of blah, 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 blah. All right, I will give you these half-angle identities. I'm not going to give you a lot of the other identities, but you'll have these. So when it says something like find the exact values of the following, and we have 7 pi over 12, do you guys remember one way that we found like tangent of 7 pi over 12 before? Because we've done things like that before. That's not a unit circle value, but could we use 2 unit circle values to find it? Yeah, do you remember how we did that? Yeah, we could do like 3 pi over 12 and 4 pi over 12 and add those together. And so then we have the tangent of a sum. And we can use the sum and difference formulas, right? Which I'll give you the sum and difference for tangent as well, probably not for sine and cosine. So we've done that before, but in the instructions on the test, it will say using a sum and difference formula, or it will say using the half angle formula, okay? So in this case, if it says using the half angle, which I didn't put on there, but since underneath this half angle, I think you can assume, you're going to look at this, and you're going to say, well, that's not on the unit circle, but this is half of 7 pi over 6. Does that make sense? Is 7 pi over 6 something that's on the unit circle? Yeah. It is, exactly. So we start breaking it apart, and we're like, okay, well, I'm going to have one of these formulas. So there's a lot for tangent. You can pick any one. Okay, I'm going to pick the first one. So I'm going to do 1 minus cosine of 7 pi over 6 all over sine of 7 pi over 6. Do you guys see why I'm putting 7 pi over 6? Because I had tangent of 7 pi over 12. That was the half angle. That was x over 2. So x then is going to be double what we have. Do you see? And then I find each of these things. So I'm like, well, 7 pi over 6 is over here. So its cosine is minus root 3 over 2. And its sine value is 1/2. Oh, you got me. Was that Julian? Cade. All right. Good job. I know. I was really excited about Cade. All right. So we have 1 plus root 3 over 2 over negative 1/2, and then we multiply through by 2 over 2 to clear those complex fractions. So our answer is 2 plus root 3 all over negative 1, which is negative 2 minus root 3. And that's our answer. Yeah, I'll give you these ones. All right, so sine of 5 pi over 12, yeah. I'm giving you the sum and difference for tangent, but not for sine and cosine. Are you guys good with sine and cosine now? Like the sine of the sum was the sine, cosine plus cosine, sine. No, because you can get those from the sum and difference anyway. Remember how we did that? All right, so this next one, so sine of 5 pi over 12. Yes, you could do this with a sum and difference formula, but if it says use a half angle, use this half angle, okay? So if we do this, so sine of 5 pi over 12, we're going to say this is half of what? What angle is it half of? 5 pi over 6, exactly. So I'm going to put 5 pi over 6 in for all of the x's, and this was 5 pi over 12 for the x over 2. So I'm going to have plus or minus the square root of 1 minus cosine of 5 pi over 6 all over 2, which is plus or minus the square root of 1 minus, so cosine of 5 pi over 6, can you guys think about where it is? Over here. So it's negative root 3 over 2. And then all over 2. Sorry, that square root's kind of all over all of it. Let's see. My pen's like a little bit off. It's driving me nuts. All right, so I'm going to have plus or minus the square root of 1 plus. Do you guys see how if I try to fix it, it's just like my pen's like not calibrated right now. Over 2, all over 2, like that. So we multiply by 2, multiply by 2. So we get plus or minus the square root of 2 plus root 3. And then the square root went all the way into the denominator. So on that last step, it goes all the way down like that. So on the bottom, I now have the square root of 4. So how can I write that? Square root of 4 is over 2, right? So it's just going to be over 2. Does that make sense? So take the square root of that bottom. And this looks a little bit funny. So we've done the sine of 5 pi over 12 before, and it didn't look like that. Do you guys remember when we did the sum and difference formulas? They always had like root 2 plus root 6 all over 2. They look like that. You did a lot of homework problems that involved root 2s and root 6s, and this doesn't look like this. This involves what we call a nested root. Do you guys see that? Okay. I'm not going to go through how to unnest that root. I always forget how to do that. There is a trick for doing it. You can leave your answer like that. But you can check it, and if you did the same thing for sine of 5 pi over 12 and you found that answer using sum and difference, and you put them both into your calculator, they'll give you the same decimal. So it doesn't look like the other one, but they're the same number. I can find what that is in a second and show you. All right, and the last kind is the ones where you have to draw the triangles. Oh, hang on. What about that plus or minus? So think about where 5 pi over 12 is. So where's 5 pi over 6? What angle was that? That was in quadrant 2. So it was a little bit less than 180. It was like 150 degrees. So what's half of that? Half of 150 is 75. What quadrant will that be in? In the first. It'll be here. This will be where 5 pi over 12 is. Is the sine of 5 pi over 12, is it positive or negative? Do you guys all see what I'm saying? Yeah, if we're in the first quadrant, it's positive, right? So do I pick between one of these? Yeah, I picked the positive one. So it's going to be the positive one because it's in the first quadrant. So you have to kind of think about where that angle is sometimes. All right, and so the next one, so I have tangent of x over 2. So it says tangent of x is equal to negative 5 over 8. And this is in quadrant, what quadrant is that when I say 3 pi over 2, x, and then 2 pi? That's in quadrant 4. Are you guys getting used to these now? It's like you should redo that first test of the semester now that you're like mastered this, like drawing these triangles. So we have opposite over adjacent. Do I put a sign on one of them? A negative? On the negative 5, right? Because it's down. The 8 was in the positive direction. I find my missing side. So I say negative 5 squared plus 8 squared equals whatever that missing side is, x squared. Or maybe I'll use y since we have x as our angle. So 25 plus 64. So I get y equals the square root of 89. It doesn't reduce down, leave it as square root of 89. So then if we want tangent of x over 2, we go back to one of these formulas. I tend to avoid the one with the square root. So I would pick either 1 minus cosine of x over sine of x, or the sine of x over 1 plus cosine of x. I just do the first one. So 1 minus cosine of x. So now that I'm talking about cosine of x, I'm not using x over 2, right? Do you guys see how that's pictured? This is for x. That angle is x, right? It's not x over 2. Do you guys see what I'm saying? Because it said tangent of x is equal to. So it's cosine of x is going to be adjacent over hypotenuse. So it's going to be 8 over root 89. And then it's going to be over sine of x, which is opposite over adjacent. So what do you think we do to make this a little bit nicer? Multiply by root 89. So we get root 89 minus 8 all over negative 5. And you can bring that negative in if you want. So it can be like 8 minus root 89 all over 5. Do you guys see what I did there? I multiplied by negative 1 on the top, which switches those two around. Okay, does this kind of make sense? Do you guys get it? So I don't have any half angle homework for you, but it is on your study guide, so you do have one that you have to try.